Listen, the biggest myth costing you an A star in Cambridge physics isn't that equations of motion are too hard. It's the belief that getting the final calculation right is all that matters. Today, we're destroying that myth because it's a trap and it's stealing your top grades. Think about it. Do you actually lose marks if your format is wrong but your math is totally flawless? Absolutely. Relying purely on that final number is honestly the most painful mistake you could make. You could execute a perfect calculation for the acceleration of freefall, nail that exact 9.81 meters per second squared, but if your presentation is sloppy, poof, those marks just vanish. And look, this isn't just me saying this. The principal examiner reports literally spell it out. They are practically begging you to realize that candidates frequently lose easy marks due to poor format, presentation, and lack of context. Your data interpretation skills mean absolutely zero if you forget proper headings and clear annotations when you're writing out kinematic data. So what's our game plan? We're going to legally steal the mark scheme by adopting an elite exam strategy. On one side, we have the myth that keeps so many students stuck at a B. Only the final calculation matters. Toss that out. The reality? Method marks dictate your grade boundary. Method marks are given systematically just for showing your analytical process, like clearly demonstrating how you rearranged a kinematic equation to isolate time or initial velocity. You get those marks regardless of what your final mathematical output actually is. Okay, let's jump right into Section 1, the speed run on core concepts and freefall. Now, the assessment objectives aren't just checking if you've memorized formulas. They're looking for three things: knowledge, application, and analysis. Notice how top-scoring candidates always connect these domains. They don't just rote-learn kinematics. They apply it to totally unfamiliar contexts. They link projectile motion straight to dynamic forces or energy conservation across the entire syllabus. They want to see if you can track a projectile's constant horizontal velocity and its vertical acceleration at the exact same time. So when you're staring down a chaotic table of free-fall time and displacement data, you need a quick win framework. Just follow these 5 steps. First, deconstruct the question. Second, extract the data. Third, select your framework. Fourth, execute with clear notation. And fifth, present it all using the right terminology. It's all about extracting those initial velocities, picking the right equation of motion, clearly showing you're working, and presenting the final values in the exact format they want. Moving on to Section 2, the answer methodology framework. This is the absolute core of our mark scheme heist. In a moment, I'll show you the exact examiner clue that changes a projectile motion answer completely, but first you absolutely need this 4-step framework because it's what makes that clue obvious. Step 1, start with the core kinematic concept. Step 2, back it up with evidence and data from the prompt. Step 3, apply your scientific reasoning. And Step 4, package the whole thing in precise examiner wording. By fully embracing this method mark strategy, you're doing something super important. You're actively proving your evaluative thinking to the examiner. You're getting points awarded systematically for showing your analytical process, justifying your decisions, and questioning assumptions. This means justifying exactly why you chose, say, S is equal to UT plus a half AT squared based on the initial conditions of a dropped object. You secure points for your thought process even if your final math goes a bit sideways under the pressure of the clock. Let's escalate the stakes a bit. What actually happens when you apply this framework to a massive, high-value projectile motion exam question? We know applying these concepts to a scenario where, say, a ball is thrown off a cliff at an angle is notoriously tough. But this strategy gives you the exact structural map you need to navigate those vertical and horizontal components without hitting the panic button. Which brings us to Section 3, the before and after answer shock. Grab a red pen because it's time to spot the errors. Look at this shocking difference. The flawed student answer on the left just lazily lists v squared equals u squared plus 2as. I mean, sure, it's theoretically correct, but it's completely empty. Now look at the top band answer on the right. It actually integrates the evidence. It explicitly ties that equation to the specific vertical drop and the initial horizontal velocity given in the prompt. It physically shows the substitution of the actual values. That's exactly how you get the marks. The principal examiner literally says the classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. They do not care if you can recite a textbook definition of a parabolic path. They want to know if you can evaluate the specific physical system right in front of you. If the question is about an electron in an electric field instead of a ball in a gravitational field, your terminology has to reflect that exact scenario, even though the equations of motion are totally identical. Okay, pause and predict. I want you to mentally stop for a second and come up with your own answer before we reveal the examiner's correction. How would you correct a projectile motion graph that lacks annotation? Think about the strict conventions we use. What is fundamentally missing if a trajectory graph has all the data points, but completely lacks clear axis labels for time and displacement? Let's see if you're right in Section 4, Top Principal Examiner Alerts. If you want to survive the grade boundaries, you need to know there are exactly 3 massive formatting traps that catch almost everyone out during high-pressure freefall calculations. Here they are. 1, forgetting proper format and losing easy marks. 2, failing to check presentation. And 3, giving answers that aren't specific to the given context. The bottom line here is that your data interpretation skills are useless if you forget proper headings, like leaving out the unit meters per second squared next to acceleration, or forgetting clear annotations on your graph. Extracting the relationship between height and time in a freefall experiment is literally only step 1. Presenting it with the correct significant figures is what actually pays out marks. Notice the split here between assumption-based reasoning and evaluative thinking. Top-scoring candidates constantly live on the right side of the slide. They're constantly evaluating the quality of evidence. They question assumptions, like whether air resistance is truly negligible in a specific experiment, and then they directly state how that would alter the final calculated maximum height or horizontal range. They don't just plug and chug numbers, they critique the model itself. All right, Section 5, unlocking the next level. Let's recap real quick, because our heist is only half done. You now have the core framework to hack the method marks for equations of motion. But there is a second trap waiting for you. Achieving that A star requires knowing exactly how command words change absolutely everything. For instance, an evaluate question about a bouncing ball demands a totally different, highly critical approach compared to a simple describe question, even if the physics scenario is completely identical. So do you know the specific command words that decide your final mark band? Leaving this strategy incomplete means you're falling right into the exact curiosity gap the examiner set for the hardest past paper skills. If you don't map your methodology to the specific command word, you're going to provide a mathematically brilliant answer to a question they didn't even ask, and that leaves crucial marks sitting right on the table. The after answer depends entirely on mastering this next framework. It's your final key to the gauntlet. Next time you see a seemingly simple freefall question, are you just going to blindly calculate the math, or are you going to stop and ask what the examiner is actually testing? Subscribe to the Ace the Exams YouTube channel. That's at acetheexams_IGCSE to make sure you're always answering the right question. See you in the next explainer.